Okay, so in this video we're going to take a look at geometric sequences. All right, so here I'm going to give an example of two different sequences. All right, now in this case, the first sequence that we see here is very similar to what we covered in the previous part of our module, or it's exactly what we were talking about in terms of there's this fixed term that we are, in this case, adding. Right, so that denoting our common difference. So again, this is not a geometric sequence, right? A geometric sequence is going to be something different. Right, now, if we notice here, right, this type of adding or subtracting doesn't really work out here, right? Because here it looks like we take away 80, but then 16, and then here like 3 and 1/5, right? So those aren't, that's not the same value that I'm subtracting or adding, right? So this is a different type of relationship, right? And in fact, while it may seem that there isn't any kind of pattern here, there actually is a pattern here, right? Now, if we take, so I'm going to look at the 20th term, and I'm going to divide the previous one. So that is equal to, simplifying, right? We get 1/5. Now, if I take 4, and again divide by the previous one, that also reduces to 1/5. And doing this one more time, we get 4/5 and we divide it by 4. This will also reduce to 1/5. So now we have a different type of relationship, right? Where before it was some fixed value that we're adding or subtracting for an arithmetic sequence. Here, what we see is we have what this is called a common ratio. And what we're doing is to get from this term, the first term, to the next term, is we multiply by that common ratio, right? 100 times a fifth of that is times 1/5 is 20. 20 times 1/5, so the relationship here is times 1/5 times 1/5 times 1/5, etc. Okay, so this is our common ratio, right? And our geometric sequence will have that pattern where we have our first term, and then at each step of the way, to get the next term, we multiply by the common ratio, right? So A1 times R. So A1 times R. Notice here to get to the third one, we would have multiplied twice. So it does exhibit that same pattern. So R squared, A1 to R3. All right, so could we get to the fourth one, we would have multiplied the common ratio a third time, right? So it's an exponent here. Okay, so what we have here is a similar type of pattern as an arithmetic where we, in this case, instead of adding, we're multiplying in another factor, that factor being the common ratio, all right? And much like in the arithmetic explicit formula, our explicit formula for the geometric, right, there's always that factor of A1, and then multiply in the common ratio. Now, how many factors of that is always one less than the term we're in, right? This is term 2. Term 3, term 4, and notice the exponents are always one less. Okay. All right. So that is our explicit formula. Now, taking it back to this one right here, let's say, all right, if I have A, N would be the first term, the common ratio, N minus 1. Okay, so let's take a look at a couple of examples here. So let's say for this example, we're asked to, given the explicit formula, find the first four terms. Of a sub n 1/3 and minus 1. Okay, so here we start with a1. Right, when we plug in 1 minus 1, that's 0. Again, 0 power does not make the 0 value. That just becomes 1. So we get 18 times 1, which is simply 18. When I plug in 2, we get 18 1/3, 2 minus 1, which is just an exponent of 1. So 18 times 1/3, that is 6. A3, 18 1/3 squared. So 1/3 squared is 1/9. All right, 18 times 1/9 is 2. All right, so that's 18 over 9. And then our fourth term here, 18 to the 1/3, this case cubed. So this becomes 18 times 1 over 27. So we get 18 over 27, which reduces to 2/3. All right, and that is kind of how we can plug in to find the terms of the sequence. All right, let's try one more example here. So let's say that we are given A2 is equal to 4. And A3 is equal to 32. Find A6. All right, and again here we are told that it is a geometric sequence. So I'll just write that to make it explicit. All right, so what I'll start off here is finding the explicit formula. All right, so notice we have two terms that are next to each other. All right, so here it should be easy to find the common difference, right? So the common ratio, since it's geometric. So our common ratio R is going to be, it's always, right, whatever term we're at and the previous one, right, divided by the previous one. So in this case, we're given that one here. We're given 3, and then the previous one being 4. So we have our common ratio to be 8. Okay, now in terms of our explicit formula, we do need the first term, right? So that shouldn't be too hard here, right? If I know A2 would be equal to A1 times 8, right? Since 2 minus 1 is 1, right? So I found R already. And I know the value of A2, that is 4. 8. All right, divide by 8, and we get 1/2 is equal to A1. Okay, so that is our first term. Okay, so now we have our explicit formula, right? We have A sub n to be equal to 1/2 times 8 to the n minus 1. And to find the sixth term, now this is easy, right? We just plug in 6, so 6 minus 1, we get 5. And then simplifying this, 8 to the 5th, whatever that is, I plug in my calculator, take half of it, our result should be 16,384. So that is our sixth term in the sequence. All right. Okay, thank you.